Next, as we have seen, in trigonometric standard limits, you have four basic formulas. Limit x tends to 0, sin x by x is equal to limit x tends to 0, tan x by x is equal to limit x tends to 0, sin inverse x by x is equal to limit x tends to 0, tan inverse x by x is equal to 1. So all these limits are equal to 1. Now how can the questions be asked? So let us take the first question. So limit x tends to 0, sin 4x by x is equal to how much? So if you are asked to find limit x tends to 0, sin 4x by x. So our formula says that if something tends to 0, x can be read as some unknown. If something tends to 0, and if you have sign of the same thing which tends to 0 by same thing, you get 1 as the answer. But here x is tending to 0, you have sin 4x by x. All these three are not same. So here you cannot directly apply the answer as 1. So first what we do is we use the method of substitution. So this is different from direct substitution. This is the method of substitution. So what I do is let 4x is equal to a new variable t. So let us take this 4x as t. Now I'll try to change the whole limit into the limit of variable t. So what I do is, as x tends to 0, according to the question, x is tending to 0. So as x goes very close to 0, where does 4 times x go? If x is very close to 0, 4x is also close to 0, right? This implies this t tends to 0 again. So now if I do the substitution in the limit, I get limit as x tends to 0, t also tends to 0. Sin of t by, what is x? 4x is equal to t, so x is equal to t by 4. T by 4. That is equal to limit t tends to 0, 4 times sin t by t. So this 4 is a constant, this can come out. And as t tends to 0, sin t by t is equal to 1. Hence, the limit is equal to 4. So you have to be very careful here. So if something tends to 0, you have sign of something by same thing, then the value of limit is equal to 1. And this, you have also seen that this x and this x has to be taken in the units of radians. So next example, let us do limit x tends to 0, sin of x degrees by x. What will this value be? Something tends to 0, sin of x degrees by x. So again here, we cannot directly use the formula 1 as the answer, because as x tends to 0, sin of x radians by x is equal to 1. So the formula is there only if this number is in radians. So if this number is in degrees, then what do you do? So you do some manipulations to convert it into some expression where I can use this formula. So that is equal to limit x tends to 0, sin of, if you have x degrees can be written as how many radians? So we know that you can write x degrees as pi x by 180 radians by x. So now when I write 1 degree as pi by 180 radians, this number has been converted into radians. Now again I use the method of substitution. Let pi x by 180 is equal to t. So as x tends to 0, pi by 180 times x also tends to 0. So this limit becomes limit t tends to 0, sin t divided by, what is x? X is 180t by pi. So t into 180 by pi goes up. So this pi by 180 is a constant. So pi by 180 times limit t tends to 0 sin t by t is equal to 1. So pi by 180 times 1 is equal to pi by 180. So limit x tends to 0 sin x degrees by x is equal to pi by 180 is the answer. Next, let us try to do this question. This you have limit x tends to pi by 2 cos x by pi minus 2x. Cos x by pi minus 2x. So if you put x is equal to pi by 2 in the numerator, cos pi by 2 is 0. Pi minus 2 times pi by 2 is pi. Pi minus pi is again equal to 0. So cos x by pi minus 2x, you are getting 0 by 0 form. And when you see this, you can very clearly see that this function involves trigonometric functions. Hence, I'll try to use the formulas. But as you can see, in the formula, you should have x tends to 0. Here we have x tends to pi by 2. And in the formula, you have to have sin x. You have cos x here. And you have to have x in the denominator. You have pi minus 2x. So this looks slightly different from what you have in the formula. So what I try to do is, I'll try to convert this into this formula. So what I do is, I'll use the substitution let pi by 2 minus x is equal to t. So x tends to pi by 2. So let us take pi by 2 minus x as t. So this implies, as x tends to pi by 2, t tends to what? As x tends to pi by 2, t tends to pi by 2 minus pi by 2, which is equal to 0. And what is the value of x? X is pi by 2 minus t, right? So what does cos x become? So cos x becomes cos of pi by 2 minus t, which is equal to sin t. And what is pi minus 2x? What is pi minus 2x? As you can see here, if you take the LCM, pi minus 2x by 2 is equal to t. So pi minus 2x is equal to 2t. Pi minus 2x is equal to 2t. Now let us change this limit completely in terms of t. So limit t tends to 0, cos x becomes sin t by pi minus 2x becomes 2t. And limit t tends to 0, sin t by t is 1. So you have 1 by 2 as the answer. So I hope this is clear. So next, let us take another example, which is limit x tends to 0, 1 minus cos x by x square. So what is the value of this limit? So if you put x is equal to 0, in the numerator you are getting 1 minus 1, 0 by 0. So this is equal to limit x tends to 0. As we know, our formulas are there in terms of signs. I don't have any formula in terms of 1 minus cos. So what I do is try to convert this into sign. So 1 minus cos x is 2 sin square x by 2. That is 2 sin x by 2 into sin of x by 2 divided by x square is x and x. So as we have seen, something tends to 0, sine of same thing by same thing is 1. So as x tends to 0, can I say that x by 2 also tends to 0? Can I say that x by 2 also tends to 0? So let x by 2 is equal to t. This implies x is equal to 2t. Now what does the limit become? Limit t tends to 0, 2 sin t by x is equal to 2t times 2t. So as t tends to 0, sin t by t is 1. Sin t by t is again equal to 1. 1, 2 and another 2 gets cancelled. So you get 1 by 2 as the answer. So limit x tends to 0, 1 minus cos x by x square is 1 by 2. So with respect to trigonometric standard limits, there is one more very important thing which you need to keep in mind. So we know that limit x tends to 0, sin x by x is equal to 1, and limit x tends to 0, tan x by x is equal to 1. That is, as x goes closer and closer to 0, the value of sin x goes closer and closer to x. So if you look at the graphs of the function y is equal to x, y is equal to sin x, and y is equal to tan x. If you look at the graphs of y is equal to x, y is equal to sin x, and y is equal to tan x. So clearly from the graph you can see that all the functions come very close as you go towards x is equal to 0. As x tends to 0, sin x tends to x tends to tan x. But one very important thing which you need to understand is that the value of sin x will approach x from the lower side, and the value of tan x approaches x from the upper side. That is, the value of sin x will always be less than or equal to x, is always less than or equal to tan x. This is the order in which the values lie. That is, if you take a very small value, for example 0.001. So if you find sine of 0.001, if you find the value of sine of 0.001, it will be very close to 0.001, but slightly less than that. So if you find sine of 0.001, it will be something like 0.00099999, so on. You can get an 8 or also something like this. So sine 0.001 is very close to this, but slightly on the lower side. Similarly, if you find tan of 0.001, you can use your calculators. I would encourage you to do that. So just turn your units into radians and try to calculate tan of 0.001. So this time you get some value which looks like this. So 0.001 tan will also be very close to 0.001, but slightly on the higher side. So I hope you understand this difference. The value of sine 0.001 and tan 0.001 are very close to 0.001, but sine approaches the value of x from the lower side, tan approaches the value of x from the higher side. So you can do the same analysis for sine inverse and tan inverse. So as we know, sine x is always less than or equal to x. If you apply sine inverse on both sides, x will be less than or equal to sine inverse x. That is, the value of sine inverse x will always be greater than or equal to x. Similarly, the value of tan inverse x will always be less than or equal to x. So even if they are tending to the same value, you need to understand from which direction they tend to. So this will be very useful in solving questions like this. So limit x tends to 0. What is integer part of sin x by x? What is integer part of sin x by x? So if you go, let us take 0 plus. So as x tends to 0 plus, the value of sin x will be very close to the value of x, but the value of sin x will be slightly less than x. So this number will be slightly less than 1. So the integer part will be equal to 0. Same is the case with 0 minus. So even if x tends to 0 minus, the magnitude of sin x will always be less than the magnitude of x. So sin x by x will always be slightly less than 1, hence the integer part will be equal to 0. Similarly, limit x tends to 0, integer part of tan x by x. What is this? Integer part of tan x by x. This will be equal to 1, because the value of tan x will always be greater than the value of x. Hence, if you do tan x by x, you get 1.000 something. Hence, the integer part will be equal to 1. I hope you understand the difference between these two questions. So, this is a very important distinction which you need to understand so that you can do these logic based problems.